After the previous class, I have discussed the questions in the assignment in projectiles up to 32. So far I have completed the discussion of the questions numbering from 1 to 32 from the assignment in projectiles. Now I am going to do the discussion of the questions numbering from 33 to 40 in this class. Look at the question number 33 on the screen. If Kepler is the maximum horizontal range for the bullet fired from a gun, then the firing angle, which should be total distance r by 2 at the same level is. So you are given the four options as shown on the screen. I'd like to work out this question. So for a given initial speed of projection, the maximum horizontal range for a given initial speed u, the maximum horizontal range of the projectile, as I discussed in the theory part of the discussion, the theory of the projectile motion. For a given initial speed of projection, the maximum horizontal range of the projectile is given by u square by g. The horizontal range will be maximum when the angle of projection is 45 degrees. It is given that r is the maximum horizontal range for the given initial speed of projection of the bullet fired from the gun. Therefore, you can write u square by g equal to r. So when the angle of projection is theta, the horizontal range of the projectile for an angle of projection theta for the same initial speed u is given by u square sin 2 theta by g. It is given that the target is situated at a horizontal distance of r by 2 from the gun. You are asked to find the firing angle, means you have to find the angle of projection required to hit the target situated at the horizontal distance r by 2 at the same horizontal line. So that means to hit the target, the horizontal range of the projectile has to be equal to r by 2. So from the first equation, u square by g is r, so u square can be written as g into r. Here r represents the maximum horizontal range. So you can substitute u square equal to g into r on the right hand side of the second equation. So r gets cancelled on both sides. Acceleration with regard to g also gets cancelled. So you get sin 2 theta equal to 1 by 2. The angle of projection theta lies between 0 degrees and 90 degrees. But 2 theta lies between 0 degrees and 180 degrees. So there will be two solutions for this. If you consider the first solution, 2 theta equal to 30 degrees, or theta equal to 30 degrees by 2, or 15 degrees. As I discussed earlier in the theory of projectile motion, that for given initial speed of projection, the horizontal range will be same for the complementary angles of projection. So same horizontal range can be obtained for same initial speed when the angle of projection is changed from 15 degrees to 90 minus 15 or 75 degrees. Therefore, answer you can write as 15 degrees or 75 degrees. So if you want to copy down the solution of the problem, you can copy down the solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause and copy down the solution of the problem. So just now I have discussed the question number 33. The answer, the second option is the answer. Not second option. Third option is the answer, that is 15 degrees or 75 degrees. Next I am going to discuss the question number 34. The time of flight of a bullet fired. Again I repeat, if the time of flight of a bullet over a horizontal range R is capital T. The inclination of the direction of projection to the horizontal is. You can observe you are given 4 options in terms of the horizontal range and time of flight of the projectile. I would like to discuss the working calculation for this question. Now, the relationship between the horizontal range, maximum height reached, and angle of projection is given by tan theta equal to 4h by r. That means if h is the maximum height reached by the projectile and r is the horizontal range and theta is the angle of projection of the projectile, then they are related to each other by the equation tan theta equal to 4h by r. So maximum height reached by the projectile in terms of the time of flight, as I discussed in the theory of the projectile motion, can be written as h equal to gt square by 8. So you get tan theta equal to gt square by 2r, or angle of projection can be written as tan inverse of gt square by 2r. You can also follow an alternate method to arrive at the same conclusion. Particularly if you are given this question in board examination, that is in the 11th class public examination or junior intermediate public examination, you have to work out the problem with the alternate method. Because any problem that is given in the board examination or in subject to type of question paper, they are supposed to solve the problem by using the formulae or results discussed commonly in all the textbooks. Should not use any ready-made results or shortcut methods in the subject to type of examination. But the previous method can be used if the problem is given in objective type of questions. So the time of flight of the projectile in terms of initial speed of projection, and angle of projection is given by t equal to 2u sin theta by g, or the initial speed of projection you can write gt by 2 sin theta. The horizontal range of the projectile in terms of the initial speed of projection and angle of projection is given by r equal to u square sin theta by g. This formula is given commonly in all the regular 11th class textbooks or junior intermediate textbooks in all the boards. You can substitute this value of u in this equation on the right hand side. So you can write u equal to substitute u equal to gt by 2 sine theta. So multiplied by sine 2 theta by g. The next step you can substitute sine 2 theta equal to sine theta cos theta. So you get g square t square by 4 sine square theta, you can write sine theta into sine theta into g. The numerator you can write on the right side sine 2 theta equal to 2 sine theta cos theta. So you get r equal to gt square by into cos theta. 1 sin theta you can cancel in both numerator and denominator. And g square by g you can write g. You get gt square by 2 sin theta. So you get sine, that is on the left hand side, you get equal to r. So sine theta by cos theta, you get gt square by 2r. That means if you are solving for theta here, or tan theta equal to gt square by 2r. So finally you get the same conclusion even by the alternate method, that is theta equal to tan inverse gt square by 2r. In case you want to copy down the working or solution part, you can copy down the solution. In case you need more time to copy the solution of the problem, you can take a pause and copy the solution of the problem. So in the question number 34, which I have just discussed now, the correct option will be the first option. Next I am going to discuss the question number 35. See the question number 35. A cricket ball thrown from a height of 15 by 8 meters, an angle of 30 degrees above the horizontal, with a speed of 75 by 4 meters per second, is caught by another field man at a height of 5 by 8 meters from the ground. How far apart were the two men? Check g equal to 10 meters per second square. I'm going to work out this. So look at the solution of the problem. So the ball is thrown from a height of 15 by 8 meters So this is the level ground here. The horizontal line represents the level ground. So the ball is thrown with initial velocity of magnitude u equal to 75 by 4 meters per second at an angle of 30 degrees above the horizontal. So it moves in a parabolic path. So it is caught by another man at a height of 5 by 8 meters above the ground at the position P. That will be the point of projection. So we choose the horizontal direction, passing through the point of projection as x-axis. So vertically upward direction as positive direction of y-axis. you're asked to find the horizontal distance between the two persons. You are asked to find the horizontal distance between the two persons, or between the point between O and P. For that, we can find the time t first taken to move from O to P. Then we can use the equation x equal to u cos theta into t. So here, the displacement y in the vertical direction is directed downwards when it moves from O to P. So you can observe that for motion from O to P, y is directed vertically downwards. So the vertical distance between O and P will be 15 by 8 minus 5 by 8 meters. That will be 10 by 8 meters or 5 by 4 meters. But it is directed downwards. So you can take y equal to minus 5 by 4 meters. That means you have to find the time at which y becomes equal to minus 5 by 4 meters. The displacement y in the vertical direction at time t after projection is given by using the formula x equal to ut plus half et square. Y equal to ui into t plus half ay into t square. The initial velocity in the vertical direction, ui equal to u sin theta. The acceleration ay in the vertical direction can be taken as minus g. So you have to find the time after projection at which y equal to minus 5 by 4 meters. And initial velocity u equal to 75 by 4 meter per second. And theta equal to 30 degrees. And g equal to 10 meter per second square. You have to can solve this equation for time t. So sin 30 degrees equal to 1 by 2. Can multiply the equation with 8 here. The next step. So write the numerical values here. Minus 5 by 4. 75 by 4 into sin 30 degrees is 1 by 2. Minus 5t square. So you can cancel 5 in all the terms or divide the equation with 5. Multiply with 8. Or you can multiply the equation with 8 by 5 to remove the decimal fractions. So you get minus 2 equal to 15t minus 8t square. Can solve this quadratic equation for a time t and consider the positive value of the quadratic equation because the time t cannot be negative. So minus 15t you can write you can do the solution of the quadratic equation or you can follow the factorization method. Minus 16t plus t minus 2 equal to 0. So you can do by the factorization method, you get t equal to 2 seconds. If you consider the positive root of the equation. So that means the ball is caught by the other field man after 2 seconds. The horizontal distance is covered with constant velocity of magnitude equal to u cos theta. So the horizontal distance denoted by x covered in 2 seconds after projection can be found by using the equation for horizontal displacement, that is equal to x equal to u cos theta into t. U is 75 by 4 meter per second. Theta equal to 30 degrees and t equal to 2 seconds. You can substitute these values and simplify further yourself. You can substitute cos 30 degrees equal to root 3 by 2. I have not completed the simplification part. You try to please complete the simplification part yourself. You substitute next step cos 30 degrees root 3 by 2. And you try to simplify it further. You can copy the solution of the problem if you are interested to copy the solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause and copy the solution of the problem. Next, I am going to discuss the question number 36. Look at the question number 36. From a point on the ground, at a distance x from the foot of a vertical wall, a ball is thrown at an angle of 37 degrees, which just clears the top of the wall and afterwards strikes the ground at a distance y on the other side. Find the height of the wall. Look at the solution of the problem. So earlier I have discussed about the equation of the trajectory of the projectile in the case of horizontal oblique projection. Equation of trajectory in terms of the horizontal range can be written as I discussed in the past in one of the problems. Let theta denote the angle of projection. Let h be the height of the wall here. The projectile is thrown at an angle theta equal to 37 degrees with the horizontal. The wall is at a horizontal distance x from the point of projection. The ball strikes the ground at a horizontal distance y from the other side. Therefore, the horizontal range R can be written as x plus y in the problem. So the equation of the trajectory of the projectile, you can use it here in terms of the horizontal range angle of projection, which I discussed one of the. So here displacement y in the vertical direction is equal, should be taken as equal to h. Let p be the position of the ball at the instant when it just clears the wall, top of the wall. At that position, its coordinates are x comma h. So h equal to x tan theta into 1 minus x by r. This is the equation of the trajectory of the projectile in terms of the horizontal range r and angle of projection theta. For objective type of problems, you can directly use this result to solve faster. But in case you are given this same problem in subjective type examination, in board examination, you have to derive this result as explained earlier. Then you have to use the same equation. In the given problem, theta is 37 degrees. And r can be written as x plus y. Can simplify it further. Tan 37 degrees comes out to be 3 by 4. So you get h equal to 3xy by 4 into x plus y. So that's the answer for the question. If you want to copy down the solution of the problem, can copy down the solution of the problem. So I have just now discussed the question number 36. Next I am going to discuss the question number 37. 2 seconds after projection. You can repeat 2 seconds after projection. Projectile is traveling in a direction inclined at 30 degrees to the horizontal. For 1 more second, it is traveling horizontally. Determine the magnitude and direction of its initial velocity. Now take g equal to 10 meter per second square. Come on, look at the solution. The velocity of the projectile will be in the horizontal direction only at the highest point of its path. Let u be the magnitude of initial velocity of projection. Let theta be the angle of projection and O be the point of projection. The projectile moves along the parabolic path. Let P be the position of the projectile 2 seconds after projection, at which its velocity V bar makes angle alpha equal 30 degrees to the horizontal. After 1 more second, it will be moving horizontally. The velocity of the projectile will be in the horizontal direction only at the highest point of its path. It means the projectile reaches the point P 2 seconds after projection, and after 1 more second it reaches the highest point. It means time taken to reach the highest point, which is called as time of ascent, will be equal to 2 seconds plus 1 second or 3 seconds. Time of ascent is given by u sin theta by g. That is equal to 3 seconds. Therefore, you can take u sin theta equal to, can substitute g equal to 10 meter per second square. 3 seconds into substitute g equal to 10 meter per second square. So you get u sin theta equal to 30 meter per second. As I discussed in the theory of the projectile motion, if alpha is the angle made by the velocity of the projectile with the horizontal direction at time t after projection, then tan alpha equal to Vy by Vx. Or you can write it as Vy equal to u sin theta minus gt and Vx equal to u cos theta. That means we have used the formula V equal to u plus at for vertical direction. For vertical motion, we can write Vy equal to u sin theta minus gt. So it is given that alpha is 30 degrees at t equal to 2 seconds. So alpha is given to be 30 degrees at t equal to 2 seconds. On the right side, you can substitute t equal to 2 seconds. And you can substitute u sin theta equal to 30 meter per second on the right hand side in this term. G equal to 10 meter per second square. And t equal to 2 seconds. So you can substitute tan 30 degrees equal to 1 by root 3. The numerator you get 10 meter per second on the right hand side by u cos theta. So you get u cos theta, that means horizontal component of initial velocity as 10 root 3 meter per second. So you can solve the equations 1 and 2 to find u and theta. Can divide the equation 2 with equation 1. U sin theta by u cos theta. You get 30 by 10 root 3. So if you simplify this, you get tan theta equal to 3 by root 3 or root 3. So theta is 60 degrees. So you get an angle of projection of 60 degrees. To find the initial loss of projection, you can substitute this value of theta in one of the equations. You can substitute this value of theta equal to 60 degrees either in the first equation or second equation to find the value of u. So I have not completed the simplification part there. You can try to complete it. You can substitute theta equal to 60 degrees in the first equation. From first equation, you can write u sin theta equal to 30 meter per second. Theta equal to sin theta equal to 60 degrees. So sin 60 degrees, you get root 3 by 2. That is equal to 30 meter per second. So from that, you get the value of u. You will get the value of u as 20 root 3 meter per second. You will get the initial velocity of projection u as 20 root 3 meter per second. So answers are magnitude of initial velocity is 20 root 3 meter per second. Angle of projection is 60 degrees. So if you want to copy the solution of the problem, you can copy the solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause and copy the solution. Now see here, just now I have discussed this question number 37. Next I am going to discuss the question number 38. The body is projected with an initial velocity of 100 root 3 meter per second at an angle of 60 degrees above the horizontal. The speed of the body at t equal to 10 seconds after projection is. I'm going to discuss this problem. So here in this problem, you are given the initial velocity of projection as 100 into root 3 meter per second, and you are asked to find the magnitude of the velocity at t equal 10 seconds after projection. The angle of projection is given to be 60 degrees. So the magnitude of initial velocity is given to be 100 into root 3 meter per second. G is given to 10 meter per second square. You have to find magnitude of velocity at t equal to 10 seconds. You can solve this problem by two methods. The first method is to find the values of Vx and Vy at the given instant of time. Then find magnitude of V. So the horizontal component of velocity projected remains same at all the instants. So the value of Vx is same as the horizontal component of initial velocity, which is equal to u cos theta. Here u is equal to 100 into root 3 meter per second. Theta equal to 60 degrees. Cos 60 degrees is equal to half. So the horizontal component of velocity of projectile will be equal to 50 into root 3 meter per second. Next you have to find the vertical component of velocity of the projectile at the given instant of time. Vertical component of velocity can be found by using the equation v equal to u plus at for motion in the vertical direction. So vertical component of velocity of time t is given by vy equal to uy plus ay into t. Vertical component of initial velocity can be written as u sin theta. The acceleration ay in the vertical direction is equal to u minus g. So at t equal to 5 seconds after 10 seconds after projection. At t equal to 10 seconds after projection, Vy can be found by substituting t equal to 10 seconds in this equation. U equal to 100 root 3 meter per second. Theta is 60 degrees. G equal to 10 meter per second square. T equal to 10 seconds. Sin 60 degrees is root 3 by 2. So we can simplify this. And 50 minus 100. So you'll get vertical component of velocity Vy equal to 50 meter per second at t equal to 10 seconds after projection. So magnitude of the velocity of projectile at any instant of time is given by V equal to root of Vx square plus by y square, where Vx and Vy are the horizontal and vertical component of velocity at that instant. Here Vx equal to 50 root 3 meter per second and Vy equal to 50 meter per second. So you can take 50 square common within the root. That will 50 into root of 3 plus 1 or root 4, that will get 2. So finally you get answer as 100 meter per second. So that is answer. So magnitude of velocity of projectile at t equal to 10 seconds after projection will be equal to 100 meter per second. You can also arrive at the same answer by an alternate method. In the alternate method, you can first find the displacement y in the vertical direction at t equal to 10 seconds after projection using the equation s equal to ut plus half at square. Vertical component of initial velocity ui is given by u sin theta. Theta is 60 degrees. T equal to 10 seconds, you can substitute next step. Acceleration Ay in the vertical direction is minus g. So at t equal to 10 seconds, y equal to u is 100 into root 3 meter per second. Sin 60 degrees is root 3 by 2 and t is 10 seconds. Substitute g equal to 10 meter per second square and t equal to 10 seconds. You can simplify this yourself. You can take 100 common otherwise in both the terms to simplify it further. Three by 2 into 10, that will be 15 minus 5. So you get finally y equal to 1000 meters or 1 kilometer. Then use the equation v equal to root of u square minus 2gy. That is magnitude of velocity of projectile. As I discussed earlier in the theory of projectile motion, the magnitude of velocity of projectile at a given height y above the horizontal projection is given by v equal to root of u square minus 2gy. If you substitute y equal to 1000 meters here and u equal to 100 root 3 meter per second, and g equal to 10 meter per second square. Simplify it yourself. I'm leaving the calculation part for you. You get the same answer, 100 meter per second, even by the alternate method. That means here you have substitute u equal to 100 root 3 meter per second, g equal to 10 meter per second square, and y equal to 1000 meters. So you get the same answer after simplification. So if you want to copy the solution of this problem, you can copy down the solution of the problem. In case you need more time to copy the solution of the problem, you can take a pause and take more time to copy the solution of the problem. Just now I have discussed the question number 38. You get the answer as 100 meter per second. Next I am going to discuss the question number 39. So for question number 38, second option is the answer. Next I am going to discuss the question number 39. The body projected with an initial velocity of 49 meter per second, 30 degrees to the horizontal. The time taken by to reach the highest point of its path is. So the time taken to reach the highest point of its path is called the time of ascent. The time taken by the projector to reach the highest point of its path is called time of ascent, that is given by u sin theta by g. It is a direct substitution problem. U equal to 49 meter per second and theta is 30 degrees. And you can give g is given as 9.8 meter per second square. So you get 5 by into 1 by 2 seconds, or 5 by 2 seconds. Our answer is 2.5 seconds. So for question number 39, you get the answer as 2.5 seconds. Next you see that means for 39 you get first option as the answer. See the next question, the last question in the assignment, question number 40. Body projected with an initial speed of 28 meters per second and 30 degrees to the horizontal, and the maximum height reached by it is. So this problem is also a direct substitution problem. The maximum height reached by the projectile in terms of the initial speed of projection and angle of projection is given by u sin theta whole square by 2g. Here the initial velocity u is given to 28 meter per second. The angle of projection is given to be 30 degrees. And g is given to be 9.8 meter per second square. So you can simplify that yourself. So you get 196 by 19.6 meter, or 10 meter is answer. So with this I have completed the discussions of solutions for the questions numbering 1 to 40 in the assignment in projectiles. So in my next class I am going to discuss the theory of projectile motion in the case of horizontal projection. I am going to discuss about the theory of the horizontal projection of the projectile motion. Of course, the horizontal projection is a special case, can be considered a special case of oblique projection from certain height above the ground. So I will be discussing the horizontal projection. After discussing about the horizontal projection theory part of the horizontal projection of the projectile motion, I will be discussing again some more problems in projectiles. That is, assignment in projectiles will be continued, numbering starting from 41 onwards.